Oilex Ltd. has announced that the C23Z core analysis has been completed. The analysis, by Schlumberger and Baker Hughes, has confirmed that the EPIV-tight siltstones at Cambay can be effectively stimulated, and that commercial gas flow rates are potentially achievable. The company has a significant multi-trillion cubic feet gas resource at the Cambay production sharing contract in the EPIV-tight siltstones that requires drilling and stimulation optimization technologies to achieve commercial flow rates. Schlumberger and Baker Hughes were appointed to complete the core analysis and to report on the reasons for underperformance of past wells. The purpose of their work was to identify any substantial impediments to achieving potential commercial flow rates and to advise on the optimal well and stimulation design required to take the project forward. Both Schlumberger and Baker Hughes are global leaders in the stimulation of tight gas reservoirs. Schlumberger was appointed to provide geomechanical testing, fluid sensitivity testing and proppant movement testing on the core. The data from these tests along with past well and production histories were incorporated into a review by Baker Hughes to assess the suitability of the reservoir rocks for drilling and stimulation and to also identify methodologies to maximize production from the EPIV reservoir. The key observations from the expert core testing and optimization analysis are as follows. The reservoir rocks have the essential characteristics for the development of suitable fractures required to increase exposure to the reservoir and to increase gas flow rates under production. This substantively removes a concern over relative rock strength in the Cambay being lower than many North American projects. Placement of the fractures within the overall reservoir section is critical to achieve optimum fracture length and direction and to ensure that the fractures are constrained within the reservoir section. On prior vertical wells, the fractures propagated vertically rather than laterally within the reservoir, thus providing little benefit. Reservoir temperature and pressure offer no specific challenges to the application of the stimulation technologies. Cleaves within the EPIV reservoir rocks are subject to modest swelling, which can be effectively ameliorated with readily available fluid additives. Proppant selection is important to maintain the necessary conductivity for sustained production. Readily available higher strength proppants than used previously are recommended. Given the relative softness of the reservoir, it is critical to avoid overflushing of proppant, which in past wells resulted in the loss of communication between fractures and wellbore, leading to significant production underperformance. This does not present any major technical challenge, instead requires active planning and management during stimulation operations. Different stimulation fluids are required to optimize the stimulation phases and ensure effective initial fracture propagation and subsequent proppant placement, whereas prior wells used a single gel-based fluid.